Okay, lesson 715. Nothing over nothing is nothing to worry about. So functions can have simple equations, but pack a mighty mathematical punch, such as sine of x over x. Investigating this function is going to deepen your growing understanding of limits. So let's look at sine of x over x. Is this function continuous for all x values? Okay, so we should know right now that functions cannot divide by, we cannot divide by 0 in math. So when we have sine of x over x, x cannot be 0. That makes it undefined. So is it continuous? No, it's not, right? So make sure your calculator's in radio mode and sketch the graph of sine of x over x. So if we go to Desmos here, right, and we graph, and let's see if I can find this, right, sine of x divided by x. And we graph this function. It looks continuous. Okay, it looks continuous. Does it have a horizontal asymptote? So if you zoom out, right, I don't know if I could get this. Yeah, if we zoom out here, it's going to look like it's approaching 0 as a horizontal asymptote there. Okay, the next question is, if so, what's its equation, right? It's approaching 0. Describe the end behavior using a limit. So the limit as x approaches infinity of f of x would be 0. Or again, we can make this, negative infinity, and it would also be approaching 0. So that's how we do our end behavior using a limit, right? So now consider the numerator and denominator as separate functions and complete the following limit statements. Okay, so we have just the numerator, the top. Limit as x approaches 0 of the sine of x. Well, sine of x at 0 is 0. Okay, then look at the bottom. The limit as x approaches 0 of x is also 0. So the numerator and denominator are both approaching 0. With the help of the graph, evaluate the limit as x approaches 0 of the sine of x over x. So if we look at that graph in Desmos, right, if we go back to this graph, what are we approaching? We're approaching 1. We're approaching 1. It's undefined, but we're approaching 1. So our limit is 1. Okay, so now it says graph sine of x and x on the same set of axes. Right, so if we graph sine of x, and then we graph x at 0, they're approaching it at the same rate, which is really what this is saying. They're approaching it at a rate of 1. Right? And that's really what's happening there. So we will learn later on that's what that means. So in the previous problem, you used a graph to evaluate the sine of x over x. Now let's look at it in a geometric perspective. So if you look here at this geometric triangle arc, right? In the diagram to the right, think of arc AB and the line segment AC in terms of x. Then imagine how will the diagram change as x approaches 0. So as that angle gets smaller and smaller, okay, at AC and AB become the same. They're really close to the same thing, which is why the limit ends up being 1. Okay, so let's consider that, and let's look at the next one. What does the limit as x approaches 0 of the cosine of x over x equal? Okay? Well, this is 1 over 0, which is undefined. So the limit does not exist. That's different, right? So when we get 0 over 0 or infinity over infinity, those are what are called indeterminate forms. And we have to do something to determine the limit. But if we get, for example, 0 over 1, we get 0. Or if we get 1 over 0 or some number over 0, that does not exist. Okay, so indeterminate form versus a actual answer. Okay, so let's look, what does the limit, so the next one here, what does the limit as x approaches 0 of x over 2 to the x equal? Well, that's 0 over 1, which is 0. Okay? All right, consider the function. So now we have f of x equals 1 minus the cosine of x over x. Right, so let's look at this graph. One minus the cosine of x over x. Right, so we're looking at this graph here. Okay, so what does it say? What is the domain? All real numbers, right? We also know x cannot be 0, right? It's in the denominator. So our domain is just all real numbers, but x cannot be 0. Okay? What is happening to the numerator and denominator as x approaches 0, right? They're both approaching 0. Okay, so it now says evaluate the limit, right? So if we look at the limit as x approaches 0 of f of x, we get 0 over 0, which is indeterminate form. But if we go to the graph, it's actually approaching 0 from both sides. So we can say that this answer is 0. Okay, because it's approaching there from a graph. Okay, think about the previous tools you have used for evaluating limits and predict what is the limit as x approaches 0 from the right of x to the x, right? So from the right, this would be like 0.001 raised to the 0.001. Okay, so you can do that, right? Or we can use the graph here. So let's see what we get when we do x raised to the x, right? What are we approaching? 1? Looks like 1. So then, predict the value. What is the value of 0 to the 0? We're going to say 1. Based on our limit and our graph. Cool. This is 715.